Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi everybody, today we are going to learn vectors. So we'll start with some theory. First of all, we need to know the concept of a point. So we represent a vector of a point by using I and j notation, where I is how many steps you move in x-axis and j is how many steps you move in y-axis. So for 2i, we move 2 steps to the right on the x-axis and 1 step upwards on the y-axis, and you get a point with the coordinate of 2, 1 or 2i plus j, and that represents a point at that coordinate. Now, let's look at how do we represent a line with a vector. So the line with equation r equals to 2i plus j plus lambda times 7i minus 3j plus 2k, we pass through a point with a position of vector 2i plus j and is oriented in a direction which is parallel to the vector 7i minus 3j plus 2k. And we can find the position vector of any point r on the line by choosing a value of lambda, which is a parameter. So let's say if we choose lambda is equals to 1, we will get a point on the line. Let's say r equals to 2i plus j plus 1 times 7i minus 3j plus 2k. Then it will equals to 9i minus 2j plus 2k, a point on the line. So imagine a line is a series of points connected together. Or you can say that it is a point plus a direction vector with an arbitrary value to represent the parameter. Then there is another way to represent a line. So for example, you have xyz, which is the r or any point on the line, equals to a starting point a1, a2, a3 plus lambda times b1 times b2 times b3. And what you can do is to separate the three equations out. So we can represent x equals to a1 plus lambda b1, y equals to a2 plus lambda b2, z equals to a3 plus lambda b3. And then we make lambda the subject of each of the equation. And we will obtain a general equation for a line, which is x minus a1 over b1 equals to y minus a2 over b2 equals to z over a3 over b3 and equals to lambda. And this is the Cartesian equation of a line. Now, let us look at how to find the angles between two lines. So consider the lines L1 and L2 with the following equation. The angle between the two lines is simply the acute angle between the vectors, representing their respective directions. This definition applies whether or not the lines actually intersect. The angle theta between the lines L1 and L2 is thus found from the equation cos theta equals to b1 dot b2 over the modulus of b1 times the modulus of b2. We take the absolute value to ensure that the angle theta is acute. So you can consider this diagram, and that is the acute angle. So we can generalize the formula in terms of cos theta and sin theta. So if you use dot product, you get cos theta. And if you use cross product, you will obtain your theta in terms of sin theta. So you must memorize these two formulas because you will keep using them later on. So a dot b equals to modulus a times modulus b cos theta, whereas a cross b equals to the modulus of a times the modulus of b sine theta. So this must be memorized in your mind because you are going to use them later. Next, let us look at how to find the length of projection of a line onto another line. So in this diagram, the length of projection of the line MN onto the line AB is given by the length of the line CD. So pay attention to the diagram. The line passing through the points A and B can be represented by the equation R equals to A plus lambda D, where D is parallel to AB. So the length of projection of the line MN onto the line AB is given by the modulus of CD, where the modulus of CD equals to the modulus of MQ. And we know that MQ, the length, is equals to the modulus of MN cos theta. As you can see, is the trigonometry property. And then now we times the modulus of D, divide with the modulus of D. And immediately, using the formula that we have learned just now, we saw that Mn dot D, the modulus, cos theta equals to the dot product. So Mn dot D over the modulus of D. And this is the general formula for you to find the length of projection of the line MN onto the line AB. Right, let us now look at an example. So given that OM equals to this, ON equals to that, and the equation of the line L passing through the points A and B is given by R equals to A plus lambda D, where D equals to B minus A, and we have OA and OB. So we want to find the length of projection of MN onto the line L. So using the formula just now we have just seen, we first need to find MN, and we need D, and then we can straight away apply these two. So Mn equals to 4, 1 minus 1 minus 2 minus 3, 1. Because you have got O and N, and then you get the answer. And then whereas for D, it's just simply using 2, 3, 1 minus 1, 1 minus 2, and you get D. Right, and then applying the formula, we will perform the dot product between Mn and D divided by the modulus of D, which is square root of 1 squared plus 2 squared plus 3 squared. And you can straight away obtain a scalar value, which is 4 over root 14, and that is the length of projection. Okay, another theory. How do we define an equation of a plane? So a plane is any two-dimensional surface. One example is the surface of a desk. Imagine a marker pen standing upright on the desk. This pen is parallel to the vector n. Observe that any line segment joining 2 points on the surface of a plane is perpendicular to n. This is illustrated for the plane pi in the diagram. The point O is the origin, and points A and R lie on the plane pi. A is a known point and R is a general point which lies on the plane pi. Thus, AR is perpendicular to n. It immediately follows that AR dot n equals to 0. And we know that AR is OR minus OA, so dot n equals to 0. And then we can let OR equals to R and OA equals to A. So simplifying the equation to become R minus A dot n equals to 0. Thus, R dot n minus A dot n equals to 0, which then simplifies to R dot n equals to D, where D equals to A dot n, because both A and n are specific vectors. And once you perform the dot product, you get a scalar constant value. And r dot n equals to d is the vector equation of a plane. Suppose you have x, y, and z for r, and n equals to a, b, c. Then substituting both of these into the r dot n equals to d equation and perform the dot product, you will get ax plus by plus cz equals to d. And that is the Cartesian equation of a plane. Alright, next, let us look at how to find the equation of a plane given sufficient information. So usually in the exam, you are given 3 cases to consider. So the first case is if it gives you 3 points. So in order to find the equation of the plane containing 3 points, draw any 2 lines connecting the points A, B, and C. For example, the lines joining AB and AC, respectively, as shown in the diagram. The normal vector to the plane pi is given by n, which is equals to AB cross AC. And the equation of pi, or the plane, is thus r dot n equals to a dot n, where n equals to AB cross AC. The second case is if it gives you a point and a line which does not pass through the point. For example, in this case, there is A and there is a line which can be represented using B plus lambda times the direction vector. So in this case, you have got 2 points as well and a direction vector. So you need 2 directions to find the normal. So how do you get the other direction? You can get it by using the point A and the point B from the line equation and minus them, and you get a direction parallel to the plane, so AB. And then you cross product with the direction which is not parallel to the line AB. So you will then get the normal of the plane. And then once you get the normal, you can basically redo whatever we have done in case 1. So we have r dot n equals to a dot n. And then the a can be the point A or the point B from the line equation. And you can basically solve for the equation of the plane in this case. For the third case, it gives you 2 lines which are not parallel but lies in the plane. So the 2 lines will intersect. So assume that the lines L1 and L2 are given and they intersect at the point A, which may or may not need to be found. The normal vector to the plane is given by n equals to b1 times b2. The times means the cross product. And so we can immediately get the equation of the plane using, again, the formula r dot n equals to a dot n. So for this case, the a can be obtained from each line equation. So L1, you have got a point and a direction vector. L2 has got a point and a direction vector. And both points will lie in the plane. So the A comes from there. Okay, next, we are going to determine whether a line lies in a plane, is parallel to a plane, or intersects a plane, and find the point of intersection of a line and a plane when it exists. So let's say if your line with the equation r equals to a plus lambda b lies in a plane with the equation r dot n equals to d, then b dot n equals to 0 and a dot n equals to d. And the second case is if the line with the equation r equals to a plus lambda b is parallel to a plane with the equation r dot n equals to d, then b dot n equals to 0 and a dot n is not equals to d. And if a line with the equation r equals to a plus lambda b intersects with a plane with the equation r dot n equals to d, then b dot n does not equals to 0, in which case the equation a plus lambda b dot n equals to d can be solved for lambda. The value of lambda thus found can be used in the equation of the line r equals to a plus lambda b in order to find the position vector of the point of intersection of the line and the plane. Okay, a lot of sentences here, but then we can get a more clearer view when we look at the example later. Alright, now we are going to look at how to find the angle between two planes. The angle theta between the planes pi1 and pi2 with equations r dot n1 equals to d1 and r dot n2 equals to d2 respectively is the angle between the corresponding normal vectors n1 and n2 to the planes pi1 and pi2. Thus, theta can be found from the following equation, the simple cost theta that we have learned just now. So you just apply them, but then in this case, the direction or the vector used is just the normal. So cos theta equals to n1 dot n2 over the modulus of n1 times the modulus of n2. And you modulus the whole thing just to get the acute angle between the two planes. So in this diagram that I've drawn, the planes pi1 and pi2 are perpendicular to the plane of the screen that you are looking right now. Okay, now we want to find the perpendicular distance of a point to a line or a plane. So for a line it is 2D and a plane it is 3D. So whether one is seeking to find the perpendicular distance of a point from a line in 2 dimensions or from a plane in 3 dimensions, the problem can be analyzed by constructing an appropriate diagram as follows. So first, you draw a line and a dot. The line is either r dot n equals to c 2D or r dot n equals to d 3D. The second step is you label the dot A and draw the line from A perpendicular to the line represented by r dot n equals to c for 2D or the plane represented by r dot n equals to d in 3D. So as you can see, I've drawn it on the right hand side. And then the line will meet at point N. Okay, so we name the N as the foot of the perpendicular from A to the line representing r dot n equals to c or r dot n equals to d. And you want to find the perpendicular distance. So the required distance is the modulus of NA or AN. And you want to draw another line from A to an arbitrary point R, which lies on the line or the plane. So let's look at how do we write them in terms of equation. So we can easily get the point R from the equation of the line or equation of the plane, and we are given the point A. So we can obtain RA, the modulus of RA easily. But then we are finding the modulus of NA. So the modulus of NA equals to the modulus of RA cos theta, as you can see from the diagram, using the trigonometric property. Next, we times the modulus of n and divide it with the modulus of n so that we can use the identity that we have learned just now, the cos identity. So the modulus of RA times the modulus of n cos theta is equivalent to RA dot n. And we can simplify the RA in terms of A and R, so RA equals to A minus R. And then we times the n into the bracket, so we have A dot n minus R dot n over the modulus of n. And R dot n for a line is a C, we can say. And whereas for a plane, R dot n equals to D. So in the case of 2 dimension, we let R equals to X and Y. And the normal is A and B. So R dot n equals to C. And the Cartesian form is AX plus BY equals to C. For 3 dimensions, R equals to XYZ, N equals to ABC, thus R dot n equals to D, and the Cartesian form is AX plus BY plus CZ equals to D. So now suppose we have A equals to XY for 2D and A equals to XYZ for 3D. The perpendicular distance for a line using the Cartesian form, we will have the modulus of AX plus BY minus C over the square root of A squared plus B squared. Whereas for a plane, it is the modulus of AX plus BY plus CZ minus D over the square root of A squared plus B squared plus C squared.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.